All right, good morning, all, or afternoon, and welcome to. All right, good morning, all. Whoops, sorry about that. So for today, I was. Hey, Oscar. For today, I was hoping on continuing with what I started last week for camera collisions. Well, not camera collisions, but moving the camera around and. Actually getting camera collisions to to collide with things, right? So first of all, let me show you what I currently have going, and we'll do the same process in a little stream Mixamo project. So let's open up this separate test project that I'm working with. Okay, so currently what you will see, there's actually a couple of things going on. I also have interpolation going, so if you notice when the player is moving, there's kind of a slow, not that slow, but there's a transition between when the camera is kind of catching up to its position. So this is the default position for the camera, and when I move it, you'll notice that the camera takes a little bit, and that's something that we can tweak to get to its kind of standing position. And also, whenever it hits something, so let's kind of pan around to this tree, you'll notice that there's kind of a smooth um, and not so jarring movement to the collision. So it kind of smoothly slides across the surface. And that's helped out by this interpolation thing. Okay, so let's get back to our thing, and let me also kind of run. Oh yeah, thank you, Oscar. Also, let me run this kind of. I'll also open my. Um, did you try with two-side materials? I have not tried that yet, Oscar. So I'm just gonna keep both of these solutions open. So this is still pretty fresh. This work that I've done. Okay, so let's go into our project, and that is in Stream Mixamo, Solutions, and Game Solution. Okay, so last we left off, we were doing the crouching change of animations, and working with that state. So in order to get the camera going, we need to look into player view. So we have playerview.c++ here, and okay, so from time to time, Oscar, I'll move this screen over here so you can see some of the comments. I don't have a little comment box or like the chat thing on my screen yet. I'm working on that. Hopefully, I'll get to it eventually. But so you can see, Oscar's comments are very useful, and just to see whenever I'm going to do a little small break in between, you'll see what I'm talking about and what Oscar is mentioning as well. So it seems to me that you're detecting collision, but the camera is located inside of the boxes, but you cannot see the faces because the normal is going to the opposite side of the face. Yes, that's totally correct, Oscar. And I'll also do because I'm offsetting on the normal of the collision as well. So hopefully that works. I'll show you what I did, and we'll go from there. So we need a couple of things. Let's do the header file and the C++ file. So I'm just going to move this to this pane here. Okay, so let's start off with the kind of the concept that I was going with this. So in order to detect my my collision, so where the camera would collide with an object, I need to shoot a ray. So I went through a couple of iterations with this. Initially, I was shooting the ray from the player's feet to where I wanted my camera to be. But that kind of quickly ran into the issue of, well, what if there's a rock on the ground and the player is in front of it, but the camera is behind it, and the ray is gonna hit that rock, or even if it's vegetation, right? It would still happen that way. So I had to move where the ray is being shot from. So now the ray is being shot from the back of the back of the head, towards the destination, which is 2 meters back. Usually, it's pretty much this view offset that you have here, and that's how I have it. That's how I have it going. And of course, this could be probably, depending on your game, could be changed up. But for my project, and just your basic kind of 3D game where you see your player, at least for now, I think it's going to be quite enough. Okay, so we'll start off with here we have we're getting the our entity, and so I've changed this up a little bit. This is based part on Ivan Hawke's blog. So if you want to go and check that out, it's a really nice blog. I'll post the link in the description, and some of the game SDK code. Let's do some rearranging. At least that's what I did for my work, and I I mean, I don't think it's really needed, but at this state, let's keep it this way. I think it's gonna be I think it's gonna work out okay. So let's I'm gonna rearrange some of these things. The view rotation I'm gonna put to the bottom. So all these positions are gonna be updated to reflect this current work, where you get the ray shooting wherever it hits. That's the new position for the camera. All right, so just gonna comment this section out here. Okay, so I'll just I guess this could be kept in here just for commenting sake. All right, so the first thing we've got to start off with is actually getting the work position, or the position of the entity. So first of all, let's create a quick vector, and we'll call this it's going to be a vector 3. So you'll notice some of the variable names for now are still some of the ones used in Game SDK. So I think they're really quite self-explanatory. So we're going to have a vector 3 called target world position, and this is going to be our entity. And I believe now this one we can access it through dot to get world position. Okay, so this is going to be our entity position, and this is usually right at the bottom of the feed. We also have to consider when we do this, if the player is crouching or if the player is standing, that might affect where we want to shoot the ray from and to. But we'll leave that for now. Just consider the player standing, and we'll add that in later. Okay, so let's see. First things first. So we got the work position. Well, basically now what we want to do is actually shoot the ray. But we want to shoot. We want to set where the ray is being shot from, and where we want to shoot it, and get the direction. We need that as well. So first of all, let's. What I'm going to do, I'm going to create another vector, and this is going to be called. I'll call this origin. right? So and we'll set this to at least for now to the target warp position. So our player's feet. Okay, and of course this can probably be optimized somehow, but I didn't get around to do that, so I'll just show you the gist of it. So we have the origin at the player's feet, and of course we'll tweak this so that it's not at the player feet, but at where the player's head is, or we think the player head is. And then we have another vector 3, which is going to be our destination. So this is where our camera is going to be. And this is going to be also, it's going to start off with target warp position, like that. And let's actually position these. So we want the origin to just origin to be where the player head is, and I'm actually gonna step this a little further back from the player's head because we also have to consider the player's proxy, so we don't want to interact with that. So this origin is going to be, got a plus equals it, and so this is something interesting that you have to be careful about, and I've run into this and I couldn't figure out what's going on. But in order for you to actually be able to offset this properly, you need this quaternion here. So now I haven't gone into quaternions as much, but I can tell you that if you take this and you multiply it by a certain value, then this origin is going to be the target warp position plus this. Hopefully I'm explaining this as best as I can. But when the player rotates, we want that offset to rotate with the player. So if you don't use that quaternion, that offset is just going to stay in one place. The player is going to rotate freely, but that thing is not going to rotate as well. So so let's multiply this. We want to kind of step this back, because column 1, as far as I can tell, and you see it here, you multiply it by an offset on the y-axis. So I'm assuming column 1 is just the way you want to step it towards on the y-axis. So we'll just multiply this by a negative 0.5. So this is going to offset it on the y-axis by half a meter. Okay, so and we also want to shoot this on the z-axis, so we can specify z by 2f. Now, if you're in a crouch state, you probably want to move this to maybe a 1.5f or something that better reflects the crouch position of your player. For now, we'll just do the standing position. I think it should be pretty simple for you to do an if statement where if player state equals crouching, or crouching and moving, then origin z plus equals 1.5 instead of 2.0. Okay, so and then let's set the destination as well. So destination is going to be pretty similar. I'm just going to copy and paste this part here. And this one, we actually want to step it further back. So for now, we'll just set it to negative 2f. 2. Okay? I meant 2. There you go. All right. And we also want to set it, its z on the z-axis to 2f. Destination. All right. There we go. Okay. So with that being done, let's actually do our ray casting. So the way they do it in Game SDK, they do a primitive kind of world casting kind of thing. I didn't really understand the what do you want to say, the way they they did this separate array world casting. So I know it's probably better for a more advanced type setup, but at least for mine it is probably going to work out good. Oscar is suggesting to use the bone position of the head, and that's a great suggestion. So that's definitely something to look into. Okay, so now let's do our array. So we've done this before. It's pretty simple. We got array hit, and we'll just call it hit. And one thing to note is, and I've seen this in Ivan Hawk's blog, is the skip entities. So this would be, and I haven't tried it fully to see how it behaves, but you can create a static, and this is going to be a physical entity, and this is apparently an array, or you create it as an array, and it's called p skip entities, and you can set it up to 10, or at least that's how he has it set up. But element 0 of this is actually going to be our entity. So our entity dot get, let's see, do we get physics from this? There we go, get physics. What this means is that once we actually create our array casting, or the array world intersection, we can add the skipped entities so that the array won't care about them. Like I said, I didn't do a full testing on it, but I'll just throw that in there so you guys can give it a try. Okay, so let's do let's create our world, our hits. So I've also seen this method being done, and I kind of like it, where you do an int hits equals so global environment, arrow, and then we got a p physical world, and again arrow, and array world and a section. And into this we need to pass a few things. So we pass the origin, where the array is being shot from. We pass the direction vector, so we'll call that dir. I haven't declared that for now, but we'll do it right after this. Okay, and then this is going to be a set of let's see where we at. And this is not the proper one. So this is going to be the object types that the array will collide with. And I'm just going to do a quick copy and paste because there's quite a few of those. So there you go. We have static, we have sleeping rigid, independent, terrain, pierceable, and collision any. I think you can probably replace these with collision any, but don't quote me on that. Okay, and then we want to pass the array hit reference, and these there's like I said, there's one hit. We want the int max hit to be 1, and then we want the skip entities, as you can see, and in this case we're just going to pass it p skip entities, and then there's one last int, and I was never able to really understand what this is about, but the way they have it set up is set it to 2. Okay, so now about our direction vector. So in order for us to calculate that, we'll just create a vec3, call it direction, and this is going to be we basically have to subtract origin from destination. So we have destination minus origin. Okay. So now we're shooting the array. That's terrific. and we want to see what happens when it hits something. So when it hits something, we want to place our camera at that hit position. Okay, so let's do this. It's so we start with an if statement, and if hit dot and we have distance, and it's greater than 0, so 0f, as well as if we actually hit something, so P collider. So now we can go ahead and set our new destination to be where this collision happens. So we have destination equals. So this is going to be comprised of hit dot point. So this is a vector of the hit location, and we want to offset this. And the way I've done it, and it seems to be working, is hit dot n, which if you hover over it, you'll see it's the surface normal, and we time that by how much on the surface normal we want to offset this. So I've done it as 0.3f. It seems to be working okay for me. Okay. The other thing to keep in mind is, and this is entirely up to you and where you want to set your origin. You know, maybe for your game you want to set the origin somewhere lower, but like I said, you can collide with other objects, and you don't want that to happen. You know, other objects that are smaller than the player, so you don't want the camera to be moved there. So initially when I was working with this is I've also did the destination. I was kind of forcing in a value. So destination equals, so on the z-axis. So I wanted, whenever it hits something, to set it to a default height above the player's feet. So destination.z, I was setting it equal to the target world position, which, if you remember, we've set it right. Let's see, where did we set that? Right here to be the entity's feet. So we have target world position. You can do a control space to do the little autofill, and so we get the z from that, and plus 2.0f. So whenever we collide with something, we always set that to 2 meters above the player's feet position. Okay, so now that this is done, we can actually jump into directly setting the position of the player to our what's going to be destination. But what I also want to do is do that kind of smooth interpolation between these. So in order to do that, I'm going to create a in our header file, and let's make it public. I guess that should be okay. So I'm going to create a vec3 and call that final position. So in our post initialization, that sounds so weird, I'm going to initialize this to set it to 0. So it's pretty easy. You can just set it to 0, and that's going to set all the coordinates inside the vector to 0. Okay, so now that we have this done, the way, because we're also going to have to implement our interpolation function. So this final position is kind of it's gonna work as, you know, okay, we set the final position to either the destination or our hit point. So then what we want to do is actually interpolate between that and the final destination. So hopefully that makes sense. It's a little confusing. It was a little confusing for me as well. But let's start implementing the interpolation, and you'll see what I mean. Okay, so right below here somewhere, let's add our void interpolate, and this is this function was actually just straight taken out of the game SDK code. It's pretty easy to find if you do a little bit of digging. Okay, so we have, let me just make sure that I'm not missing any of the parameters. We have a float, which is actually going to be called actual. So, and another one, which is the goal, so where we want the interpolation to end. And we want the speed. This is how fast our transition is going to be. And there's also a limit, which I'm not entirely sure what it does, because it's already set to 0. But there's some things that I guess you got to take with a grain of salt. All right. So once we have this in place, let's do create definition, and here we have it right here. Okay. So this is kind of a little bit, you know, you got to get your head around it a little, you know, somehow. So, and one thing that I missed in my parameters, I apologize for that, is actually the frame time, because that's important on how fast this goes, because it's, you know, based on your computer. So let's add this in also as a float, frame time. Okay, so let's make sure we place this in here. Oh, actually, sorry, it's right after the speed. Okay, and float limit. So let's start adding some of the stuff in here. So the way this works, and I'm going to try and do my best explanation of it. It's all based on delta, which is kind of the change between our goal and our actual position. So I know we talked earlier about this being kind of the direction. So whoops, this is a vec3, sorry. So like I said, this is going to be a little bit of a, you know, kind of tough to explain it. Oh yeah, thank you, Oscar, for the suggestion. It's I did that earlier, but then I forgot to add the parameters, so I didn't really go through it again. All right, so like I said, this is going to be actually minus. I was kind of thinking, what's up with that squiggly line, but it was just I had to subtract it. Okay, so in this function, this is kind of where that limit comes in, and like I said, I'm not entirely sure of the whole underpinnings of this interpolation. You can probably do some research on that if you'd like. So I guess if this is greater than 0. At least the way Crytek has it implemented, 0.01f, then we want the float. There's actually, I couldn't find any comments on this function, so like I said, I'm trying to explain it the best I can. So there's a float length, apparently. I think it's length. So, and this is going to be the delta, which is our vec3 from right above, which it seems to me like it's more of a direction. And this is going to be delta dot length. I think it's length. So now if we have this len, which is actually, sorry, this is an if, is greater than limit, and then we can kind of divide it by the length. Like I said, I really suck at explaining this function because I know what it does in the end, but I'm just pretty much copying it from my test case. So times equal limit. I'm sure that if you start breaking it down, it's probably going to make a lot more sense. But in the end, you'll probably see it a little better because actual. So our kind of current position that is just going to have to be transformed or changed to delta times the minimum value between frame time, this is where our frame time comes in, and multiplied by speed, and apparently 1. So, like I said, hopefully some people with more math skills than me understand this a little better, but yeah, I don't have that much of a math knowledge. So let's see, what is this little squiggly thing about? Did I miss something here? Oh, yeah, I guess I went overboard with the with that, and it's still kind of upset about something. This was created as a void. No, matching plus equals for that. Oh, well, there's something else that I missed. So the way the definition works, and of course, I made a terrible mistake here. I'm not actually passing floats. I need to pass vectors because we don't care about floats in this one. But there's an overload for this function that Crytek did, and I kind of used it as well. But you know, to my shame, these were actually vec3s. So I was kind of thinking, oh, this must be something wrong. Okay, so we have vec3s here and here. Alright, so there we go, that's much better. Okay, so now that we have this in place, the way they have it in Game SDK is that excuse me, so they're also using this this frame ID, and again, I'm trying to kind of understand it a little better. So what they do is they create a constant int, and this is going to be this frame ID because it's basically kind of subtracting from your current frame versus the previous frame, and I'm guessing if it's greater than a certain number, then we set our final position to the destination, and if it isn't, then we can do the interpolation. So this is again going into the global variable and accessing the renderer and get frame ID. Okay, one thing that we also need to add in here is our last frame ID, because this is at the end of this if statement, we have to set the last frame ID to this frame ID. So let's actually call this, because it's a frame ID. There we go. Alright, so let's create that in here, and it's just an integer of called, let's call it m underscore last frame ID. Okay, so in here, let's create our little if statement. So if we have this frame ID, come on, there we go, and we subtract our m last frame, and m underscore last frame ID. And if this is greater than 5, and this is, you know, it might help to do a little bit of experimenting and see what happens if you change the 5 to something else. So if that indeed happens, then we have our final position. We set that equal to our destination. And else, in here, we'll do the interpolation. So let's call this interpolate function. And so what do we want to pass it? We want to pass it to final position, and we want to pass the destination because this is where we want to interpolate to. And for me, I gave it a speed of 5.0f. If you give it a smaller number, then this is just going to interpolate a little, or it's going to move the camera a little slower to your destination. And then we pass it to view params. View params dot frame time. Okay, so once this is all done, we want to set the m underscore last frame ID to our this frame ID. Okay, so we can remove all this stuff now. I might just keep it there for now. Okay, so final thing is view params. We want to set the position, right? And we set that equal to final position. And final position, come on. There we go. Okay, so we have the final position declared at the top. I think that might actually be it. So let's do a quick compile and see what happens. Okay, that turned out good. So let's fire this thing up, and we're in Stream Mixamo. Let's see if any of these collision work has done anything. Okay, that's a horrible level. Thought I had something that looked had a little bit more things in it. Okay, that looks like might do something. Okay, so let's see what happens if we rotate the camera. Whoa, that was not expected. It did track the collision, but then it figured out that it wants to move it all the way up. The good thing about it is, if you notice that the interpolation works pretty nicely. I guess I had to say something about the one thing that works. Alright, so let's take a look and hopefully figure out what was going on here. Okay, so let's just make this a little bigger. So let's take a look at, well, I think this might be a little bit of an issue here, right? Because we don't want X, we want Z. It was actually putting it at, usually I think the allocation was somewhere around 250 or something. So let's compile again and jump back in and see what happens this time. Alright, so let's jump in game, moving around, hitting the wall, and as you can see, the camera stays there. And it actually turned out kind of better than my test case, I think. And that interpolation helps a ton with some of the issues I was running into with this was that without the interpolation, it was pretty jarring. Like the whole movement across the surface was pretty horrible. I really hated it. Okay, so now we actually have you know, something going on that's you know, it's gives you a pretty smooth experience, and the camera doesn't go through things anymore. So we actually finished up quite early with this stream, and I think it turned out quite okay. We got to the point that we wanted. So thank you all for stopping by. Like I said, if you have any questions, you can try and drop them on YouTube when I post this. So the Oscar asks a question, and this is something that I'm probably not going to be able to answer. Is like, how do you take care of frame drops in the interpolation? I thought you should take care since last frame and use a delta for the interpolation. That's a good suggestion. This 5.0 arbitrary speed interpolation, it may be working for you as your current frame rate. Oscar, I don't know if you're losing anything. Unfortunately, I did not get around to do too much experimenting with how the frame time works for when you get it through the view params. I'm not sure if it's the same as the way you get it in. Let's see, where do we have a as in the update function? I'm thinking it might be similar, but I'm not sure about that. But that's a really good point to look into and test it on a different hardware or something. So so with that being said, Oscar, thanks again for your input. This is very useful, and thanks again everyone for stopping by. And like I said, this will be posted to YouTube here shortly. And till next time, you guys have a great week coming ahead. All right, take care, everyone.